In this problem, there are n roadworks, and for each roadwork, we're given S and T, and a roadwork occurs from Si minus zero point 0.5 till Ti minus zero point 0.5. And there are q people who are all standing at coordinate 0. And the ith person will start moving from coordinates 0 at a certain time di to the right with a speed of 1. And what we want to do is for each person, we want to see how far they can walk. And once they're blocked by a blockade, they'll be stopped there. And if they aren't blocked by any blockade, they can walk forever. So we just output -1. So the key thing to notice is that the values for x is 10 to the 9 and s and t are 10 to the 9. So a O of n approach would be too long. So what we have to do is we have to be smart about how we analyze our s and t. So if you look at s minus x, then any person who starts, let me jot this down. So for any s, right, s minus x until, and then this is some person here, until t minus x, any person in that range will be blocked by this blockade. Actually it'd be less than or equal to, right, because it occurs before si, right? So because of that, what we could do is we could just keep track of when we're given a blockade. Since we know that between s minus x until t minus x, any person who starts within that range will be blocked by that blockade, we can just keep track of the start times and which ones are affected by blockades, and then we can just go through each person and see whether they're in any of these intervals, right? So how do we do that? So first, let's just read in the input. So int n and q, yeah, n q c and n q. Then we want to keep track of s minus x, and so for each s and t pair, we need to keep track of them on their own. So s minus x, and then we need to know this is the start of a blockade, right? So we'll give this value 1, and then we also need to keep track of how far along the blockade is, because we need to output where they get blocked, right? And the same logic is we also need to keep track of if it's the start of a blockade or an end of a blockade. And if it's the end of a blockade, let's just keep it as -1, and also x to know which one we're taking out. So let's just do that. So so the best way to store this would be in a set pair int close. Okay, and then for n, we are given st and x. st and x, right? So then st dot insert. So yeah, we insert what, s minus x, then we insert 1x, and then again st dot insert. Now we do t minus x and then a -1x, right? So then the next q lines are the starting times of the people, right? So now what we can do is in st we just insert, what would it be? We would just insert the value d that we're given, so that's when it starts. And then since this isn't an insertion of a blockade or we take off a blockade, we need to create a new type, and let's call this type 2, and for the last value let's just give it in as I, so we want to know its index. And if the key thing here is that this value 2 should be bigger than 1 or minus 1. Why is that? Because over here, when you're given S and T, the blockades actually happen before, just a bit before. So S minus 0.5, T minus 0.5. So the adding of a blockade or the taking off of a blockade will happen just before the actual S and T. So since these two operations occur before this, because this occurs at a integer time, this occurs 0.5 before, if S minus X is equal to D, then this will occur first and then this will happen. And the same thing, if T minus X equals this, then the taking off of this blockade will occur prior to this person going to that step. So that's why this value has to be bigger than these two values. So now that you've inserted everything into the set, we need to know if it's blocked or not. So for each of these Q people, let's create some answer array that'll keep track of whether they're blocked or whether they walk forever. And so then, okay, so let's create a set called blocked, and when there's a value in it, that'll be a X value of a blockade that is currently in place. And if there's no value in it, that means that if any person we see comes through, they aren't blocked by any blockade. Okay, so now we're going to go through our set st. So for, what is this, pair int equals xx from st, if xx dot second dot first equals 1, that means we're going to start a blockade, and then we would block dot insert x dot second, else if xx dot second dot first equals -1, that means we're taking off a blockade. So block dot erase xx dot second, and then otherwise, then that means xx is a person. So if blocked is empty right now, that means this person won't be stopped by any blockades. So therefore, answer of for a person, we know its indices by this value. So x dot second equals -1, because they can go forever, because they won't be blocked by anything. Otherwise, they'll be blocked by the first blockade that's by the blockade that starts the earliest, that will affect the people in this range, right? So since we have a set called blocked, ans x dot second equals block dot begin, and that should fill up all the entries in our answer array. So then just for int, I don't know why in answer cry. Okay, does this work? Oh, I didn't see that. What's the error? Oh, okay, it's another xx dot second. Where are you? Oh, there we go. Okay, copy that, paste that, and our answer should be what? 2 to 10 minus 1, 13 minus 1. Oh, perfect. Okay, just copy that, and this should work. And voila.